Hello, ladies and gentlemen. Welcome to most innovative, futuristic, and we will try to make it most dynamic session of today's business agenda. We'll talk about hydrogen, gas, and how they compete and fight for our future. My name is Sergey Malozemov. I lead scientific show on TV. The topic is quite close to my interest, and this is not my first time at the event organized by Russian Railways. It will be 3 years since all of us proudly and trembling look at the news from Germany when they launched first Siemens hydrogen train, and it's been many years. When we look at our gas locomotives in the center of Russia, in Urals, for instance, in my journalist point of view is revolution doesn't take place in this, how should I put it, in this alternative future, when finally rails of all country and all of the world will be filled with the hydrogen gas trains. Is it needed? How much money it will take? We'll try to discuss all these during this session. Precise name is from zero demand to the zero CO2. I'd like to introduce our debate participants, and we try to make debates. It will not be presentations. Everyone will have 2 minutes. We'll try to divide our speakers in 2 conventional groups. The group that is on the right side of the stage, in the left side, if you look from the hall, we call it the group of hydrogen. These are speakers who agreed that hydrogen is more promising than gas. Vladimir Andreev, Deputy Director of Chief Engineer of the Joint Stock Company, Russian Railways. Please welcome him. Alexander Yermonsky, Deputy General Director for Technical Development from Transmash Holding. Alexei Kashin, General Director of the OOO Energy. And the second, more crowded group, we call this group of gas. Leonid Kuznetsov, Deputy Director of the Center of Engineering, STM. Alexander Manekhin, Executive Director of Promzheldortrans. Kirill Lyatskin, Director of the Joint Stock Company, Kriomash. And Yuri Babko, First Deputy General Director, Chief Engineer of Design Engineer, Nifty. And the experts in the first row of the hall, Sergey Drobzhev, Technical Director of RM Rail, Yuri Saikian, General Director of Institute of Problems of Natural Monopolies, Pavel Ivankin, President of Institute of Research of Railway Transport Problems, Dmitry Kuznetsov, Director of Business Subdivision of the Rolling Stock from Siemens Mobility, and 2 experts with us online, Boris Lapidus, Chairman of the Scientific Council of Russian Railways, Anton Moskvin, Vice President for Marketing Business Development of the Joint Stock Company, Rosatom Overseas. Now then, let's set the pace for this discussion, and we will vote. Please show QR code on the screen. If you point your smartphone, we'll send it to the page of voting. It works out perfectly from the back rows, the experts. You don't need to vote online. You will express your opinion with your voice. So the question, formulation of the question, what new type of propulsion is the most promising? Please select after the variant natural gas, hydrogen, energy accumulators, biodiesel, maybe some other. While participants online in this whole vote, I'll ask speakers in the order like you see it on the stage. Please give me your answer. You will expound. Please use microphone. Please press the button, switch on your microphone. Hello, dear colleagues. Since I'm opening the hydrogen part, I'll say that hydrogen is the most promising story out of presented ones. Just what is your voice? What do you vote for? Good afternoon. I'll say like this. The short-term hybrid, mid-term gas, long-term hydrogen. If you select in the gaming scheme, what would you vote for? Hydrogen. Welcome. If you look into the future, machine should be safe and reliable. Perhaps if we look at the tendencies of the far future, I'll agree it's hydrogen. So you voted for hydrogen. If you look at standpoint of Russian Federation, it will be hydrogen and gas. Welcome. I, as the city in the gas sector, I will say perhaps natural gas. In the future, will expound your thought. Welcome. As the producer of rolling stock and locomotives, we develop a line of different rolling stocks for different fuels, including the future. We should anticipate variants. We believe that gas, in terms of readiness, is the next step compared to the current level. Next step in terms of readiness is hydrogen, and some of the variants, especially hydrogen, requires hybrid scheme. Speaking in modern digital language is prerequisite for the hydrogen scheme. Thank you. Kirill? I'll say that no one said I'm for electric accumulator for the future. I'll believe there'll be final way of propulsion for all big vehicles. Welcome. Let's make me outstanding hybrid gas and the accumulator. Please show on the screen the voting outcomes. How the forum participants vote in the room and online. Please show me the distribution of votes, if it's technically possible. Now then, almost draw. Hydrogen is slightly ahead, but the batteries and natural gas are not lagging behind too much. So slowly, without conflicts, it inclines to everything. But let's try to add concretics. I give the floor to Vladimir Andreev for first 2-minute speech. What is the future? What locomotives with the alternative traction are most promising, you believe? I want to say that during speeches we'll have countdown, so you have to watch your time. Good afternoon once again to everyone. If we talk about the future now already gaining the silhouette for a long time. As for the gas machines, with TNK and Sinara and gas in reality is the near future. This is our joint agreement on the hydrogen with TMK, with Sakhalin and Rosatom, where we realize concrete passenger projects. This is our agreement with Sinara and Rosnano on hydrogen locomotive, heavy machine, including development of hydrogen we see in the city agglomerations, including alternative types of environmental fuel. These are locomotives hybrid with batteries that work inside of metropolitan areas. All these are living true projects that were built by the agreement. Same question to Alexander Manyakin. What is the future? What locomotives will be the most demanded? Colleagues say properly, it is necessary to be based on the time. We in 2019, together with locomotive builders, producers of locomotives, the leading institutes and specialists of industry, prepared specification for a locomotive that we have to see after 5 to 10 years. This is diesel machine with 2 diesels, modular design, all these parameters that allow us to save. Industrial transport is focused at savings, not environmental friendliness. But in horizon after 2030, it will be liquefied gas. In the future, of the remote future, it's of course hydrogen. Thank you. We'll talk about money. Let's talk about environmental friendliness. How we get zero CO2. Not always hydrogen is green fuel. It is divided into the ways of gaining it. There are sometimes green H2. Just a few days ago, President Putin mentioned carbon tax on the parts of European Union as the unfair competition. We know that just yesterday there was a leak into Kommersant newspaper regarding new strategy that provides seemingly wide-scale watering of the swamps in our country. We'll have more CO2 captured, and we thus will avoid portion of the payments that are threatening us. How technology may help us? Are we ready with gas or hydrogen to cut down on emissions? I'd like to ask this question to Alexei Kashin. Yes, colleagues. Seems that the formulation of the question is very correct. If you talk about emissions of CO2 from rolling stock, the only variant to avoid this emission is full electric propulsion, whether hydrogen or a battery. With the battery, we need to understand whether there was emission during charging of this battery, so the origin of electric power. With hydrogen, we need to know about the origin, so we need to divide the way of gaining it 2 ways: electrolytical or thermal decomposition or non-electrolysis. If it was green, we get fully zero chain of emissions. To this question, I add the question of cost of emission of CO2 will play a certain role. There are different ways of computing life cycle, but only variant of carbon print on board is using of the hydrogen air fuel cells and using the hydrogen carbon-free trace. Batteries, I agree with the colleagues, segmentation of the market. Energy content of lithium on board is enough. We need hydrogen, despite of my love and my opinion that this is truly a big future, where we will come finally if the content of lithium in terms of safety, about 20 kilowatt hours per kilogram, quite possible. With hydrogen, we can talk about more than 1,000 watts per kilogram. In terms of storing, we can dream about 2,000. Cost of technical characteristic of this solution, all other variants with the internal combustion engine of this or that type of onboard engine is the carbon footprint. Tendency is to have limitations that is growing. It's a technological link comes number one. It seems that we need to look at the horizon because this agenda is gaining momentum. I think the demand peak for such technology without carbon is ahead of us. Analogy is the hydrogen locomotive is only gaining speed. Seems like a compromise. In 3 to 5 years, we'll see that it is not timely. This risk should be taken in consideration. Also, don't forget about claims of ecologists to the recycling of lithium-ion batteries. It's a bottomless question, the claims of the ecologists to the recycling of the fuel cells. Despite of my location among the hydrogen optimists, I know that membranes used in the fuel cells and electrolyzers and the solid polymers of Thor Organics in terms of recycling We work for a long time on this. There are white spots. Yet, if you look at this product in terms of life cycle, and together with colleagues from NIJT and NICT, I'll repeat, even considering all the factors in terms of ecology, hydrogen is number one, running ahead of everyone in terms of generation on board. Inlet, Crew Director. You work on gases, including hydrogen. No, we make equipment for scenario, for locomotive working on the liquefied natural gas, work on the hydrogen locomotive. How environmentally friendly it comes out. Look, few aspects. When we start to work on gas, in terms of ecology, we discussed only cancerogenic substances emission. Only 3 years ago, we spoke about greenhouse gases. Now, if a locomotive has emission of methane and leaking methane more than 4% out of the charged into the tank volume, even the LNG locomotives becomes more dangerous in terms of the greenhouse emission rather than electric, because methane and CO2 is 25-1. So we need to understand that even locomotive working on LNG will have to be ideal in terms of gas consumption without emission to atmosphere, and gas that comes to the LNG machine should come without leaks. Today we see that monitoring from the space shows colossal leaks at the pipelines in Russia. If you have LNG not at the gas field but by railway, which Russian Railways is planning to organize near some railway station, when it comes, it will emit so much greenhouse gas, and compare environmental friendliness of the engine is senseless. As for hydrogen, once again we said that the Sakhalin project plans for steam reforming with the pumping is very inefficient technology in terms of greenhouse gases emission. It will be much more dangerous to use hydrogen than LNG. It will be a worse story. Today's practice of Exxon in Australia shows that more than 50% of CO2 while generating H2 is impossible to pump into the layer. The Australian government allocated grant for this machine and it didn't work out. They don't have positive experience.
So Sakhalin can become a volcano where GHGs will erupt and will produce hydrogen. So I agree with Alexei on this. Only hydrogen that is obtained by electrolytic from water can be environmentally friendly. And as long as we don't have it, the LNG is quite an effective solution for locomotives. Thank you very much. I'm sure that those who proponents of hydrogen will not agree with you. Would you like to? I would agree with you mostly. But as regards winning hydrogen from natural gas, I'm sure that Kirill knows that there are other ways of fuel processing, of obtaining hydrogen from methane. For instance, cracking or other ways to capture CO2 or transform CO2 into useful chemical composition by adding tails in the form of green chemicals. This helps us to look at it from a different perspective. But this market is still very immature. And if we look at the commercial technologies, then Kirill is right. But if we look at it from other perspectives, when we can obtain hydrogen from natural gas, while at the same time getting technical carbon as hard matter, or if we can use this CO2, which we receive as effluent gas, rather than inject into the formation, turn it into useful projects. For instance, liquefy it and turn it into acid. Question is whether do we need so much acid? No, we don't. And what will happen with the CO2 then? Now, this question becomes a complicated one. And in my opinion, it would be too early to put a full stop there. If we obtain hydrogen from natural gas with carbon capture, utilization, storage, etc., and this hydrogen is totally bad, no, this is not the right approach. There are lots of various answers to this question. And if we just take CO2 emitted into the atmosphere and we obtain blue hydrogen or green hydrogen, we all know that hydrogen has no odor, has no color, but these conditions are already very well known approach. Well, any hydrogen, technical hydrogen, A grade, if we take Russian standards, will be good enough. But what was generated in the process of obtaining this hydrogen, now this can get a third life, a second life. I would look at it from a broad perspective. We should take into account not only CO2 or methane leakages as greenhouse gas, we also should at the emission of NOxes. And if we look at these fuel gases, maybe even sulfur will play an important role. I'm afraid you're going to kill the entire environmental project. No. You know, if we look at it with an open eye, then we should simply realize what the next stages would be. We should be able to predict several steps ahead. And I think that we, as the country, and we as the Russian Railways, have a whole set of ways to become technical leader by using this strategically right approach and by understanding the next steps. We can also act as a market maker, if you will, with respect to green energy, because the heavy transport will definitely create a special niche that will gravitate, that will create technologies of new generation. But how can we approach this? How can we estimate our next steps? So what I'm trying to say that we need to look at it from a comprehensive perspective, and then this entire discussion will have a new life. Because all the approaches that we are discussing have many more secondary advantages than we see on the face of them. Thank you very much. I would like to ask the same question to the level science. My question goes to Yuri Babkov. Good afternoon, dear colleagues. You know, again, from the point of view of environmental friendliness and the carbon footprint, I think we need to set the priorities. Because the carbon footprint is one song, it's about climate, but environmental friendliness is about NOxes and other hazardous materials and other emissions that go together with the combustion in the internal combustion engines. If we look at it from the point of view of environmental friendliness, then clearly hydrogen is the most environmental friendly material. There's nothing you can do about it, because all you get is the water, steam, which is actually also a greenhouse gas. Now, what we see in the middle is engines that work on gas, natural gas. But if we compare them against diesel engines, the content of NOx is just 1/6. CO2 goes down 25%. We did mathematical modeling. We simulated how much would the carbon footprint be when a 700 to 7100 train would transport from the east test ground to Komsomolsk. If the diesel eco is 100%, then what we receive that the hydrogen loco would be 44%, with fuel efficiency would be 60% on liquefied hydrogen received by conversion from methane, and gas piston loco would be 76%. So we shouldn't look at using hydrogen without addressing the issues of its production clearly. And one more question that I'd like to ask to my colleagues who propose to use hydrogen. Where would be this threat that regular water will cost more than diesel fuel? Where is this threat? You know, I will try to I will try to answer on behalf of all the proponents of hydrogen. As regards water, yes, indeed, if we talk about purified, sweet water, then we hear this question quite often. Furthermore, it should take into account the cost of water treatment. But water treatment is required for many technology processes, not only for these generators that we have discussed. For any other production cycle, this is something that we need too. So this story can entail a long chain of discussions. But I believe that as for Russia, we don't be afraid. We don't need to be afraid to expect that there will be a shortage of water. For instance, if we take 1 liter of water, we will have 1,234 liters of hydrogen and more than 1,000 liters of oxygen. And then after we oxidize the water, we get the hydrogen, we get it water. And many years ago, when we showed this in Asia, there were people who drank this water that we get as the gas from the engine of the car. So what we would get at the end is air, which has slightly less oxygen, and there's water. You can call it even steam, but the temperature is low, is 65 to 80 centigrade. So this water gets back into the atmosphere and it returns to this cycle. It will become part of the water reservoirs. It will never go away from our blue planet. So my reply to this question, no, we're not afraid of any water shortages. Although we need to take this into account clearly, because there are regions where people don't have enough water to drink. And here, we need to treat water to produce fuel from it. Yes, asymmetries like that can occur locally. All right, thank you very much. Let's wrap up the environmental aspect. Dmitry, Siemens Mobility. Thank you. As regards the zero emission, as my colleagues Alexei and Kirill mentioned, yes, we need to look at it not only from the point of view of a locomotive or electric train, but from a broader perspective. And in this respect, we need to point out that gas technologies would not allow reaching the zero emission target. This is quite clear now. But there's another group. I would call it electric solutions. What I have not heard in our discussion yet is that alternative traction, alternative zero emission is a niche solution. We should not forget about electric supplies. We need to electrify Russian railways. Russia has always taken the lead in this respect. And main lines, long lines, are electrified quite successfully. And this is already a green solution with a zero emission potential. Now, next we see hydrogen and electric batteries in this group. And these three positions, electrification, hydrogen, and electric batteries, we need to understand where we take electric power from. Well, we should also bear in mind that we need to develop the green electric generation. We need to take into account in this respect that wind, solar, or renewable energy must serve as a basis for this zero emission as the final result of using our railways. We in Russia have a great potential for development in this respect. For instance, we have seen that in Germany, Siemens battery-based trains have a wide infrastructure to use. Wind generation, other types of generation can serve these trains. If we look at this, we can decide whether we can use it to provide power to trains and what energy we're going to use, be it coal-based or gas-based or wind-based at the entrance to the system. Or we can do electrowinning and we can produce hydrogen, or we can use batteries for short distances like 60 to 80 kilometers. Thank you. Yuri Sakan, Institute of the Issues of Natural Monopolies. What do you think about environmental friendly? Yes, I'm not going to repeat what my colleagues have said. All I want to say is the following. Today, this year, the European Union adopted its hydrogen strategy. And I should say that there's no such term as green hydrogen there. We see electrowinning hydrogen more often. This is the approach of the EU. Any hydrogen that has been received by different technology, be it gas-based or oil, but Rosneft produces hydrogen as well. So the hydrogen will definitely have a different color. I fully agree with my colleague. I don't like coloring the hydrogen in various colors, but it will be simply different color. It will be not green. Now, as regards what our colleagues have said about electrification, you know, I believe that we did not do the right thing when we forgot this issue. Only I wouldn't focus on renewable sources that much. Because in any case, if we look at the gist of the matter and not the policy of the EU, then we see that nuclear-based generation or hydro generation is clean in this respect. It is green. Again, talking about colors. Now let's just think very briefly. Our generation, renewable generation is less than 1%, and nuclear-based generation is 17%. Why should we build windmills all around Russia or solar batteries? Yes, we'll definitely forward your question to the EU. Thank you. But let's keep close to the railway practice. What would manufacturers of equipment propose? Is it gas? Is it hydrogen? Hybrid? Alexander Yeremovsky, Transmash Holding. You know, TMH, as a global leader and global manufacturer, has tried almost anything. It is quite rightly said hydrogen is being tested at the moment, but let us look what we already have. For the past 10 years, TM19 locomotives have been used already. It was designed and built in year 2011 at the Bryansk machine building plant. We know all about how it works, all its pros, all its cons. And we're quite confident in technical terms. So we're now designing an upgrade of this gas loco, TM29. The base is TM19, but with all the new technologies. We have designed a new gas-based engine. You will be able to see it beside our building. This is our new engine that we have designed at our engineering center and have made at Kolomna. It's 9 GMG. Now, at the same time, we manufacture locomotives of a totally different type. MK2, for instance, an innovative locomotive, a hybrid loco. It's basically a unique product worldwide. It's a battery and contact locomotive. What is important is all these locomotives fit into the concept of the platform. Our basic platform is TM23, the beautiful piece which you can see here on exhibition. We take a pride in the fact that we've been able to show our latest development. TM23 is an example of a platform-based approach. It has now 2 diesel engines, Kamaz engines, but we can take the diesel generator away and put any source, hydrogen source or a battery or any other source of power. Now, this platform offers us an opportunity to test any technology. Now in practical terms, TMH is a private company, is a for-profit company. So this is why hybrid technologies are the most promising ones. They can be used right away. You can estimate the pros, the cons, you can show the economic efficiency. Why do we work on gas as well? Because we will see effective gas locomotives in the future.
First of all, shunting and mainline locomotives on diesel, no doubt. This topic is being elaborated well enough. The main is economics. How we can show economic effect of using of gas fuel. And long-term future, of course, hydrogen is at this time the principal priority because fully ecological quality achieved through hydrogen only. At this time, hydrogen technology, of course, is losing to diesel. Loses because of the specific traction, specific weight of the machine, and economically the price of hydrogen. We work tightly on developing, and Dave mentioned the project of the rail bus on hydrogen. We will realize it, we'll show all technical points. The main thing will be creation in Russia of the market of hydrogen. We must be sure that hydrogen is available. I'm not talking about the colors. I'm the producer. I, at lesser extent, is interested. We need to know that hydrogen is available. How much does it cost? And then we can count on the contract of life cycle and economical efficiency. Thank you very much. Please stay fit into 2 minutes time slots. Sinara Kuznetsov. Sinara is also a leader in realization of the projects for rail machinery. It has status of innovative partner in the Salon 1520. I'll remind, since 2012, Sinara company is in business of locomotives with batteries. We made locomotive TM9H with lithium-ion batteries. Next was gas locomotive, together with NIFT in 2014. I'll remind you that together with the industrial institutes work on digital technologies that not only work on the power machines, but in terms of the optimization that saves pollution and fuel. As for the new technological arrangement, we work on product lines. Key product lines is small shunting locomotive based on gas, and 2022 will present this locomotive for Russian railways and a special version for industrial transport systems. New trunkline locomotive, the 35, with alternative variants, modern diesel with good ecological pollution, gas fuel LNG based on diesel family by conversion of diesel into the gas piston. Next level is the hydrogen. Let me remind you that we work with Russian railways for the sake of Russian railways in 4-party agreements. We're also technological partner that provides fuel cells. Don't forget about infrastructure, whether gas infrastructure, whether hydrogen infrastructure. We should not forget that we have practical effect to make locomotives that practically utilized in practical conditions. The Russian railways pays great attention to the operation. The weight of trains and the blocks are various, starting from the eastern network where infrastructure is present but not so much developed, the northern horizontal route, ending with the western routes where shunting and trunkline locomotives demanded, such as Kaliningrad province or Moscow-St. Petersburg corridor, where environment should be protected for freight and passenger trains inside of the urban areas. We switch to ecological fuel. I mentioned key timelines from 22 to 27. We roll out new products. I'd like to point out that not was stated yet. We, as an industrial company, maker of the locomotives, pay attention not only to locomotives but the method of production, because production of locomotives is rather imprinting on environment. STM developed ECG strategy that contributes to a Russian railway strategy in terms of optimization of resources and resource saving and energy efficiency. That is also important point. Also note that the track machines also important, because track machines and track works important element in terms of environment, and all the issues raised during this discussion also impact truck machines and truck processes in terms of the pollution, switching to hybrid source of energy, usage of batteries, and automation of operations. All these works we conduct in close collaboration with the universities, scientific institutes that are present at this panel discussion, with industrial institutes of Russian railways, and with engineering center of railway machinery, with whom we collaborate tightly in Skolkovo. Thank you very much. Please don't forget about time. Does Siemens have anything to add? Yes, of course. I'd like to mention something else. As for batteries and hydrogen motion, often we face with necessity to advise customer how to select purely a battery or to select hydrogen. First of all, the answer is both are niche products when there is no electrification. As for batteries, solution helps to squeeze the most out of existing one. If an operator has electrified infrastructure and the last mile is low load block, not electrified, it's reasonable instead of investing to launch battery operated machines. Also important is topology of these sections and climatic factor. We're faced with the situation that cooling and air conditioning does not impact much on the life of the battery as the heating in winter. In places where it's cold, we use hydrogen. Hydrogen is good for long distances, about 600,000 kilometers without recharging. Hydrogen is full replacement for diesel trains. And we talk about complex topography. Hydrogen will cover traction solutions where electric battery cannot cover. Yuri, will you draw a bottom line? What seems to be the most promising out of what the producer said? Reply to the question? I think that, in fact, yet electrification, first of all, and then secondly gas, and the third is hydrogen. In fact, one small fact, just recently there was publication of hydrogen strategy of UK that straight spoke that solution is electrification of full electrification of railways. It's talking about promotion of low carbon footprint. Yes, Kirill. Few considerations. First of all, as the producer, I'd like to say that we work on railway machinery. In particular, we make blue rail car. It's mobile electrochemical hydrogen station that will accompany locomotives. Thermal or diesel electric locomotives. Hopefully, at the end of this year, we will show the prototype of this rail car. As for electrification, I'd like to say that there's a problem of our northern territories that are difficult to electrify in terms of the further maintenance. The rains that will bust electric catenaries, they will not allow to draw Yamal, Khanty-Mansiysk power lines, Tikhonsky railways, portion of BAM. These are costs that will be higher than switching transport to hydrogen or gas. The most important question is infrastructure of the charging stations in terms of gas and hydrogen. Nick T, with whom we collaborate, we entered into discussion who will make this infrastructure. As far as we can say, the LNG infrastructure is duty of Gazprom. Experience of working with Gazprom and switching automotive transport for gas is failure. Gazprom gas fuel is 10 years old, but what happened? Nothing was gasified in Russia. Look at how many automobiles in China working on gas and how many work in Russia? Practically zero. Moscow took a look and switched to electric buses, skipping gas buses. No one does. For big entities, not interesting, it's too small. I'm certain if a company does talk to Yakutsky LNG, to Novatek, to make them involved into creation of the entity for this creating of the charging infrastructure, creation of hubs. If it's next to the seaport, so the ships can be charged with the fuel. Transmash Holding said in 2011 they showed first LNG locomotives. How many locomotives with LNG? Only 4 locomotives. It charges in Urals. It was private company. Uraltransgaz was taken by Gazprom, and nothing is evolving. When it was there, the Northern Railway was developing LNG. There's nobody to look at. Private initiative should be everywhere. In production, likely we have Senara. Nothing in infrastructure should be taken away from Gazprom. Otherwise, the direction neither hydrogen nor hydrogen nor gas. Let's talk about rolling stock. Yes, allow me few statements. There was territorial connection. I'd like to support Kirill from other points of view. We discuss about whether we can build electric power line or draw a pipeline for gas. In terms of local generation, creates different picture in terms of the feasibility study. What kind of energy carrier is preferable? Hydrogen looks absolutely differently. And development of the cluster linkage is the future of the country. First statement. The second statement, if you look at logical component, anything related to burning of the fossil fuel and any machine that works according to Carnot cycle or combustion, internal combustion engines, there's a departing technology, investment of any funds. The story is limited. Specific material content, efficiency ratio will not improve. Ecology will be harsher. It's a dead end. It's good to create new industry. Another story to support statement about infrastructure. Aside from clusterization, we could look at this as mobile infrastructure. If the timetable of trains changed, mobile machines and energy carriers can be switched. We cannot change the power lines. It's possible, but economically it's not feasible. The mobility infrastructure. During last Scientific Council of Russian Railways, people spoke about this. Another colleague, another test, talk about machinery. It is clear that all locomotives will not be substituted. We can talk about upgrading of rolling stock for alternative traction. Question to Vladimir Andreev from Russian Railways. Colleagues discussed interesting things. I see many opinions. I'll briefly answer a question because it's short. Many of you, when you walked around the exhibition site, saw the benches. Perhaps everyone saw the benches. Do you know what is this? I'd like to explain, talk about hydrogen life cycle. The plastic packs are environmentally friendly. Everyone says no. But this product proves otherwise. 5,000 plastic packs, 80 kilograms of sand. It preserves the wood. Ecological production of plastic sacks. Applications are many. Second question discussed by everyone that we face is development of technologies. Today we don't have technology development level. In the country house, I'll show you example of technology development during 25 years. I decided to change old TV set, old Sony, heavy hardly could pull it. Instead, it's 32 Samsung. My wife is small, fragile. She was able to carry it. 25 years of technology development. And she had new life and took the Gypsy family took old TV. They use it, works, and will continue to serve for another years. Producers with open eyes, go and do. It will be demanded. We discussed batteries. These projects, we're waiting for them. We're burning. In Ivanovo, we connect diesel locomotive to multiple units. So give us keys, so the hybrid gas, we need them. We can sign agreement today. Tomorrow, any amount we will digest. The trunk line locomotive, shunting locomotive, give us hydrogen. Hydrogen and Sakhalin will do. Yes, we understand. It's beginning. Discussion. What will be the life cycle of the project? No project will not work according to the normatives. We will not understand what's in operation, what's nuances. When we start doing this, we'll understand what we face. It will go faster. In fact, the state will make decision, make up its mind. As for the essence of your question, we understand that our expectations from producers, I may name them expectations. We should do them. The fleet of existing diesel locomotive is huge. We have 2 institutes. We keep our corporate science. Nishta and Nifty are working on design documentation for upgrading of the mass applied machine TM17 in 2021-22. We'll finish the project and start realization of the project. The company is going through all routes. It calls the colleagues, do it. So did we stop carrying coal? We brought it where? We brought it to the east. We'll carry it, let me assure you, for very long years. That's why everything about hydrogen, gas, batteries, any combined ready for production is expected by us. So we don't need to couple diesel locomotive to last. It can carry it to Ivanovo. So it can carry itself. When the catenary is over, it drops the pantograph and works on hydrogen. That's for modernization. Does anyone have to add something?
Now, with the open vision, very briefly. Like my colleague has already said, our colleagues at the research institutes have been working on the projects to upgrade 116U and 118DN. And here I would like to make a request to the industry, to the manufacturers who have also been designing new gas locomotives. The tender sections of these locomotives, which are basically a big vessel, should one way or another be unified, so that the Russian railroads wouldn't have any problems. The tender section from the STM, TMH, and from the modernized locomotive. This should be a unified, a universal module. TMH, Sonara. What about modernization and upgrading? You know, what I can hear, that our client needs this equipment and we're ready to manufacture it. But there's a very important question about any innovative equipment. What do we compare against? What is our benchmark? We have a diesel locomotive. If we take it as a benchmark, and if we make a gas locomotive, then gas equipment costs more. How can we compensate the cost of this more expensive equipment? Do we compensate it by reducing the cost of the fuel, right? Yes, we save on fuel, that's right, if we use gas. But unfortunately, so far we couldn't prove by estimates that we would be able to make this gas-based equipment at a profit. So we are facing a dilemma here. How can we obtain an economic effect from introducing this innovative equipment? We have been working quite actively on this together with the Russian railways, holding lots of meetings. But there's a dilemma. It is quite clear that we need a new and innovative locomotive. But economically, how can we justify its price? How can we make this project profitable both for the manufacturer and for the client? This is still a question that needs to be answered. With your permission, very briefly about this transition period. When we go away from traditional fuels to more innovative fuels. Well, firstly, the problem about the new power unit has been already raised. It's only at a level certain technical maturity and production maturity. So to be able to do transition to the new locomotives, we need new energy sources. I would like to remind you that this transition has been quite difficult in all the countries. I would like to remind you about the German experience. Trains on hydrogen or ship on hydrogen. So far, this project has been working in the negative area. And the federal land, which operates these locomotives, has been so far issuing subsidies, subsidizing this operation. So transition from conventional locomotives to new locomotives will be a problem. We know that the Russian railways have been making high demands to us with respect to reliability and the economic aspect of such equipment. But there's always a demand for transition period. We don't use government support, government subsidies, which people need to design the technologies and to survive the transition period, which will definitely have to be there. Digital testing is one of the questions that has to be answered. These help to proceed from hardware-based testing into mathematical simulation. We have raised this question with the management of the Russian railways. During the testing, this mathematical simulation would have to replace traditional hardware-based simulation because this will make the technology cheaper and more affordable. Alexander Manekin, what do you think about upgrading? Well, talking about upgrading, transport was the first one to see that simply to be able to that we need to transform the transport to alternative types of fuel. But what we see at the moment that technically it is not viable to upgrade our equipment, but also from the point of view of the legal regulations. The technical regulation of the customs union implies that if we upgrade our equipment, we'll have to have it certified as well. This is a mandatory requirement, and it will be certified in accordance with the requirements posed to new equipment. So it will be basically a new locomotive, and the cost of this locomotive will be that of a new one. So it is not economically viable to upgrade existing locomotives so far. Thank you. So I would like to ask Pavel Ivankin from the Institute of Issues of Railway Transport to summarize the result of this discussion. Now, talking about upgrading and development. I can say the following. In the past, it took quite a long time to stop using steam engines. Back in the 1920s, we started the transition from steam engines to diesel engines. And at the end of the 1950s, it was decided that we start using only locomotives. So today we see a definite trend. The major part of the railway network is covered with electric grids. And we see what the manufacturer says. The trend is quite clear. But it will require some support in the unelectrified area, and furthermore will require some support with respect to shunting operations. We see certain limitations there with respect to electrification. We also see that today diesel has proven very efficient in certain areas. Now, the transition in future to gas, we have heard today that there are 2 gas locomotives that have been operated for quite some time. But what do Russian railways say? They say, yes, this is a cool equipment, but what about the cost of the fuel? And if we look at the cost of this fuel, then we see that this is why the replication of this equipment has been stopped. If the price is good enough, then we will continue our movement. Russian railways are a national monopoly, and its prices are controlled by the government. And while the Russian railways have made a very interesting step towards using new technologies, these technologies should be designed to reduce operational costs. And if all the messages that I've heard today will result in the fact that Russian railways say in the midterm perspective that they will invest in these technologies, then I agree. But I see that so far manufacturers didn't have enough financial stimulation to make innovative equipment because this takes financial costs. 2, Russian railways need to invest in testing to get some effect. So before this, all these chains are linked, all these links are linked, we will not have this result. Now, this is probably the main task that we're facing now. I would still slightly disagree with my colleague. I'm very sorry. I really hate this. But when there are material errors, I would beg to differ. It's not about the price of the fuel. No. This was regulated in the agreement. Now, the problem is that there's no gas turbine. And the manufacturer today is not capable of supplying the machines in the amount that we require. Manufacturing 1 to 5 gas turbines a year would not cover the problem of 200 locomotives on the Baikal-Amur main line today. No, it's not about the price. They simply are not capable of producing this. We have discussed it with the Minister of Trade and Industry. This is what the problem is about. But if Sinara solves this issue with the Minister of Industry, that will be very good. But so far, today, all our consultations have demonstrated that this is the main obstacle. And it's quite a serious one as well. So the gas turbine is the main obstacle. So what we're discussing now is engines of which are much more realistic. So this is where the problem is. While in the past the question was about the price, the machines which are operating now on the Baikal-Amur main line, the TMH machine, for instance, we see that if the issue with the turbine is solved, then it will be competitive in terms of its price. So at the moment, we have simply delayed this a bit. You know how much does it take to produce a blade? You know how much good quality blades are produced? Only 40 to 45%. Yes, the upgrading is underway, and Kuznetsov has been doing this as well. But so far, production lags far behind the level of requirements. Yes, but in any case, there are certain limitations for you, right? That prevent you from implementing this. Yes, this is why we have done our best to regulate it in this 4-party agreement. You're quite right. The economy is all linked, but we said that the price of the fuel must be so many percent of the diesel fuel. Everybody agreed. Gazprom built its infrastructure, and everybody agrees. And Russian railways would buy gas locomotives, and manufacturer would make these locomotives. But so far, before this is linked into a single chain, it will be quite difficult to tackle all the issues. So there are problems at all the levels. This is why we are now discussing hydrogen. Seemingly, the prospects are much longer. but it is much more feasible with respect to production than even this gas turbine, for instance. But it is impossible to get it. Thank you. Now, let us discuss the biggest pain point, the infrastructure. Who is supposed to build this network of charging stations and how? Sergey, you have the floor. Yes, good afternoon, dear colleagues. Our MRail is about 9,000 cargo cars a year, about 8,000 containers a year. Why did we decide to begin working with LNG and hydrogen? We have historic routes. It routes from the Rosaevka chemical processing plant, so we know a lot about it. We have worked with the vessels under pressure, with cryogenic vessels too. Now, I would like to get back to the name of this forum. The name of the heading of the forum is from zero demand to zero emission. I would like to add 100% negative emissions. They should also be reduced to zero. Now, these are two ways that our colleagues have outlined. And I think this will take a lot of time because there's no single understanding of where to go. Some people prefer hydrogen, others LNG, still others prefer hard fuels. I would fully agree with the representative of the Russian Railways that something needs to be done to be able to end somewhere. With respect to LNG, we do have equipment, we do have machines. We, as the manufacturer, you can see our container there for LNG, and we're ready to keep continuing in this area to create the infrastructure with a view to the client's requirement. I think that Russian Railways, as one of the biggest clients in Russia, with respect to development of green energy in particular, should consolidate these efforts. Because this is not only about the technology and equipment, this is also about the regulatory framework and federal support. And you need the one-stop shop approach. Otherwise, it will take us a lot of time, a lot of effort. Gas manufacturers would do one thing, other manufacturers would do other things. Yeah. So we talk about the issues of gasification of particular areas, but I would suggest that we look at a more intensive, more aggressive policy with respect to creating maybe one of the largest clients for the green energy, the Russian Railways. Thank you. Now, scientists, researchers, you have the floor. Who should organize the infrastructure of charging stations? Who's in charge of safety? Because as we all know, hydrogen is a very explosive character. How can you organize this properly? Well, what can I say? We have gained a lot of experience of organizing charging stations for gas motor locomotives that are charged with LNG. The main question here is about creating the proper regulatory framework. We have this framework for LNG. And basically, this entire technology has been tested and proven. As for hydrogen, as far as I know, there's no such framework at all. So this is why we think that efforts must be made to take the best experience from Europe in this respect and to bring it over to Russia. Because the regulatory framework is the cornerstone that will enable us to rule out the human factor. Thank you. Boris, you would like to add something, right? Boris Lapitos, online. Good afternoon, esteemed colleagues. Well, first of all, I would like to point out that we have had a very professional discussion. All the participants are highly professional, and they have touched upon most of the aspects that must accompany transition to clean energy on the railway transport. I should note here that Russian railways and motor transport account for more than 80% of cargo turnover, and this is done on electrical traction. So talk about alternative decarbonized traction. We should first of all focus on local transportation. The locomotive distances and the shunting locomotives. Everything that the Promysl Trans does, this also falls under this umbrella. I fully support the opinion that the Russian railways can and are capable of becoming a leader in promoting technologies that will replace diesel fuel with more environmental friendly fuels. But undoubtedly, we also should bear in mind that environmental friendliness should be affordable price-wise. And economy plays a major role here. I think that we need to look at the following important steps to introduce both hydrogen and natural gas. We need to localize our markets. In particular, these are sectors that take special environmental attention. For instance, we saw that around Lake Baikal, there are more than 100 shunting locomotives. Clearly, attention to Baikal requires that this is the area where hydrogen is introduced as one of the top priorities. Talking about what should be introduced first, natural gas or hydrogen, I can say that the participants have made a quite clear case that this is not an alternative, either or. No. It will depend on the readiness of the technology, on the readiness of the infrastructure, and on the price of producing the energy carrier, with a subsequent assessment of the consequences that generation of the production of hydrogen or delivery of gas can mean. It is also quite critical to understand what our long-term tasks are. These tasks should be identified on the basis of research. I hope that Russian Railways will take into account that it is necessary to do this predictive design, and that sectors where hydrogen and gas traction can be used should grow wider. And it is quite important to mention here that the price of production and delivery of locomotives on gas or natural gas traction will depend also on the number of orders placed by the Russian railways. So this research is quite critical to understand the scale of the market. It is the size of the market that we're going to develop, both for the hydrogen or natural gas traction. Now, in terms of natural gas traction, we should be talking not only about the gas turbines, like aviation turbines are used, but we should also bear in mind the developing technology of micro turbines, 100 kilowatts, 50 kilowatts, because practitioners from the defense sector say that these turbines can be easily united into clusters and bring the total strength of such units to 2 or 3 megawatts with comparable dimensions, or even smaller than dimensions of the diesel-based traction. I fully support this statement that special focus should be made on the introduction of infrastructure on the part of private companies. Private companies would never come to a new segment when the government is not interested in it. This is why government programs for the development of hydrogen and natural gas-based traction must be adopted in the very near future. They must be designed, and they must regulate these issues of generation of energy sources and of supplies, and take of the equipment that will transform energy into traction.
The locomotives themselves unquestionably use only new locomotives. We need new projects and technical solutions on upgrading of the diesel locomotives, switching to another alternative ways of getting energy. Boris Moiseyevich, I'm sorry, our time is catastrophically out. Not only talking about Vladimir Evgenievich supporting your statement, the example that you used, we should not orient strategy at the solutions that already achieved. We will always be lagging behind because technical progress develops through exponent. We will orient at technical solutions that are ready. That's why we need to stimulate. It's not only railways, it's also the state, federal programs, R&D institutions. Unfortunately, railway transport does not receive support in terms of creation of the state programs. In the project of AutoNet, Avianet, there is no railway net, despite of the fact that we wrote proposals. I think that at the current conference we'll have additional source of pushing agenda across. Boris Moiseyevich, I'm sorry, our time is absolutely out. Let's give the floor to Anton Moskvin from Rosatom Overseas. I'll ask Vladimir Andreev to draw the bottom line of our session. And implementation of new technical solutions, always precious. The right example, the first electric locomotive with the mercury rectifiers. The cause was the harmful effect of operation. Important step of switching to electric traction. I'm sure that due to initiatives that today are made by Russian railways and scientific foundation with our private companies that are in business of hydrogen and gas, and scientific complex of Russian railways and Rosatom and Rostec will solve this problem, and Russian railways will be one of the most noticeable players on the market of decarbonization of traction, not only in Russia but in the world. Thank you. Let's give the floor to Anton Moskvin from Rosatom Overseas, and we'll make summary. Anton, your point of view on what was stated. 2 minutes. Dear colleagues, can you hear me? Yes, we hear you wonderfully. Thank you very much for invitation and participation in this discussion. It's very important and timely. I agree that we truly have to understand every kind of solution. That both solutions have advantages and disadvantages. It's important to observe the needs of the customer and offer the most advantageous solutions to the customer. We talk about short-term future. And highly probable is that it's a short-term. I'd look at the far future, remote future, especially if priority is on the side of the customer. Full exclusion of the CO2 emission. Besides, we should not forget that natural gas is not everywhere in our country, and the hydrogen can be made with the usage of the energy of different sources. Again, renewable sources, renewable generation. You talk about Rosatom. Today we work a lot on development of hydrogen solution for industry, transport. We conduct several pilot projects. As colleagues from Russian Railways and Transmash Holding noted, a lot of elaboration is done. Example is Sakhalin. we should say that there is no significant obstacles to realization of the advanced projects. There are many successful examples, successful projects in UK, Austria, Germany, Belgium. In this project, we're responsible for infrastructure. We elaborate the different scenarios, production by conversion of methane, delivery to the charging stations. According to one scenario, production by electrolysis by the charging complexes. They have cons and pros. I think that for different regions will be different set of different solutions in terms of the cost. We need to look at the supply chain, look at the realization of one of the scenarios. Talking about cost, I heard the discussion. The key challenge today is the launch of such projects. The cost is decisive factor. Part of the cost of hydrogen is part of the cost of locomotive. Diesel obviously is commercially efficient solution in the number of the regions, but the cost factor should be taken into consideration, except for creation of the electric network. Hydrogen solution is rather efficient in different countries, and development of priorities in Russia, in our country. And the Russian railways has set of priorities. Anton, thank you very much. Sorry, time is out. Our time is our trouble. I'll ask the director to show on the screen. Anton, I'm sorry. I'll ask the director to show the results of the final voting. That will show whether numerous optimists of alternative power, whether they could convince the audience that the bright future is quite close to us. Please show QR code on the screen for voting. The experts and participants and the speakers can also participate if they wish so. Questions like this: when finally mass implementation of gas and hydrogen propulsion will be implemented? The feeling since 25, since 30, 40, since 50, or never? We'll never start mass implementation of gas and hydrogen traction. Few seconds for voting. I think it will be enough for everyone. Who wanted to vote? Give me results. '30th is winning. More than half of voters believe that it takes less than 10 years till the moment when we finally can see the victory of alternative energy right before our eyes. I thank the participants of this discussion. Of course, we were not able to talk about many things: how to decrease the price of hydrogen, how much is the state subsidy. It will remain in the professional lobby talks. It will be the topic of the next forums, where we will pleasingly meet each other again. We'll have interesting discussion about the future, how the future will be, and the representative of those who produce equipment and operate equipment will create the future. So wish luck. Thank you very much for participation.